So let's give you guys some more practice. So we are still on Earth. Gravity on Earth is 9.8, but let's round it off to 10. 10 meters per second squared. We're going to fire the cannonball at 90 meters per second at an angle of 67 degrees. Find out the exact location of the cannonball after 14 seconds. Okay, so when you fire it, you don't know where 14 seconds is. So work out the time it takes to get to the maximum height. So let's say if it takes, let's say, 10 seconds to get to the maximum height, then you know 14 is on its way down, so it will be somewhere over here. Let's say the maximum height is 20, then you know 14 is going to be around here. So the cannonball is rising. So well, anyway, if it's rising, work out the height of this cannonball and the distance of this cannonball here. If the cannonball is over here somewhere, then work out the height of this cannonball and work out the distance of the cannonball here. Okay, so find out the location of the cannonball after 14 seconds. Okay, so press pause and have a go. Okay, so to do this here, hang on. So to do this here, break up this diagonal velocity here into its vertical component and its horizontal component. Then jump to your velocity time graph, and try and work out this T max here. Once you've got the time it takes to get to the maximum height, then you get a rough idea of what's going on. So here, well, at maximum height, the velocity will be 0. So put 0 into this V here. So this thing here then becomes this, okay? And then basically work backwards to find out the time it takes to get to the maximum height. So this T here, when you put 0 into the V, this T here represents the time it takes to get to the maximum height. So it's blah 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 blah. So this is the time it takes to get to the maximum height. Now that we know it takes 8.28 seconds. So if you look at this here, when you fire the cannonball, it's going to be like this. Well, it takes 8.28 seconds to get to its maximum height. So 14 would be over here, somewhere over here, rather than over here, because it takes 8.28 seconds to get to the maximum height. So 14 is not going to be over here. It's going to be over here. So now you have a rough mental idea where the cannonball will be after 14 seconds. It's somewhere on the right hand side. Okay. So hang on. So you've got your maximum, your time it takes to get to the maximum height. It's given by this here. So now going back to your velocity time graph. Remember, now that we've got the time, we need to work out the actual height of the cannonball. So now that we've got the time it takes to get to the maximum height, now we need to calculate the actual maximum height. Well, the actual maximum height is given by the area underneath this graph here. Okay, so to find out this area will be this times this, okay, and then divided by 2. So this height here is given by this, and then times the across here, which is given by this, and then because it's a triangle, cut it in half. Okay, so that would give us an area of this, and remember the area represents the maximum height. So now that we've got our maximum height, our diagram will look like this. This is the maximum height. We know that to be 342.98. Okay, and well, we've got the maximum height. Now we're going to free fall to this stage here. So what is the time of free fall here? Because the cannonball, when you fire the cannonball, when you fire the cannonball, it will get to its maximum height, and then it will free fall back to this level here. You see, back to this level here. It will free fall for this bit. This is the free falling bit. The question is, how long did it free fall for in terms of time? Well, if it takes 8.28 seconds to get here, and we want to know the time of the cannonball at 14 seconds, then we need to know the time it takes to free fall. Basically, remember that the time it takes to get to its maximum height is 8.28, and then it's going to free fall the question is, how long is this free fall? Well, that's given by this 14. Take away this time here, 8.28, like this. So this time here, well, jump to your calculator to work this out. That would be 5.72. Okay, so we are going to free fall for 5.72 seconds. So now you would imagine you standing on top of a building and dropping a cannonball for 5.72 seconds. Well, this formula should be ingrained inside your mind. So put this into this t here, and then blah 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 blah, work backwards to find out h. So h is given by this. So what that means is that if you free fall for 5.72 seconds, you would have traveled 163.59 meters. Okay. So now the maximum height is given by this. We free fall for this bit. So the height of the cannonball at 14 seconds will be given by this. Okay. Now maximum height is given by this. We free fall, and then after 14 seconds, our height is given by this bit here. Okay. Now we need to find out the distance here. Okay. Oh, don't call it range. So the distance is don't call it range, because range would represent the whole range of the cannonball right to the end. But because we're right in the middle, so let's just give it a different name. Let's just call it distance. Okay. So now imagine you and your either your dad or your mom, it doesn't matter. That traveling this at this speed here, meters per second. Okay. Traveling horizontally. So the distance will be speed times the time. Well, time in this case is 14 because we are driving for 14 seconds. So it's speed, which is here, times the time here, which is 14 seconds here. Okay. And then that will give us this. So the distance is given by this thing here. Okay. Yeah, you could jump to a calculator and get a decimal answer, but we can and we are allowed to just leave as this. Okay.